Discussion. Titanite, with its considerable variation on chemical composition, is a highly sensitive indicator of oxygen fugacity, FO2, and water fugacity, FH2O, during the evolution of geological environment, for example. The chemical composition of the analyzed titanite shows that the substitution, Al, Fe3+, plus F equals T4 plus O2- and the substitution, Al, Fe3+, plus O equals T4 plus O2- were the most significant substitutions in these titanates, figures 6 and 7. In both substitutions, it could be up to 30% of T replaced by aluminum and ferric iron. According to their F, Al, and Fe3+ concentrations, the titanates considered as low Al titanates could be analyzed. Their low F and Al content could be well compared with contents of both elements in similar magmatic titanates. The partial Al plus Fe3+ excess over F indicates the presence of Al involving substitution reactions such as, Al, Fe3+, plus O equals T plus O. The origin of titanite that is usually concentrated in light spots is thought to be formed with albite-enriched component plagioclases, oligoclase, and quartz on the expense of andesine and tianite as expressed by the following reaction. Similar late magmatic reaction is supposed for titanite origin from I-type granites occurred in the Tribec Mountains, Western Carpathians, Slovakia. This suggestion for the origin of Titanite-Spots Granodiorites in the Austrian Mahlaviertal by late magmatic crystallization was presented in the past by Rupp et al. Late magmatic origin of titanite and Titanite-Spots Granodiorites and tonalites from the Furstenstein Pluton is supposed by Chen and Siebel. In the past, the origin of these Titanite-Spots granitic rocks in the Furstenstein Pluton was given in detailed discussion of older papers and also supposed by Troll. Especially according to old detailed studies of Titanite-Spots Granodiorites and tonalites from the Furstenstein Pluton, Drescher, Fischer, and Troll suppose that titanite in the light spots originated by late magmatic and or younger hydrothermal crystallization. In all these cases, biotite served as a source of T for titanite, and titanite is most likely originated from a reaction involving biotite and probably a northite component in plagioclase, during its denorthization. Incorporation of the Re in titanite is realized by the coupled substitution. Partial enrichment of Re, especially Se and La, is significant for magmatic titanite, especially for titanite occurred in alkalic magmatic rocks and lamprifiers. Incorporation of Nb and Ta is realized by the following reaction. Both the exchange reactions, 2 and 3, are significant for primary magmatic titanite. The Nb and Ta enriched titanite was described from some granitic pegmatites,